Okay, dear students, we were completed 5.2 exercise in the last class. Okay, now before 5.3 exercise, we will see some concepts. Two concepts are there. First concept is derivatives of implicit functions, and the second concept is derivatives of inverse trigonometric functions. See, from derivatives of implicit functions, we are not going to derive any standard derivatives. But from derivatives of inverse trigonometric functions, again 6 standards we are going to derive. That means d by dx sin x we have seen. Now we are going to see d by dx sin inverse x, like sin inverse x, cos inverse x, tan inverse x, all 6. Those are also like standards you have to note down and you have to take it. Okay. First, let us see derivatives of implicit functions. What are implicit function? Implicit function means not explicit. You see here, the function normally what we take always f we take. You see, like this I am writing. Say f we take, or else f of x we take, or else y we take. This we take as a function. That means if any function is there, y is equal to sin x. If you want to derive dy by dx, okay, y will not be there here. Y will be one side, dy by dx. But you see here, 2 times y is there. Y plus sin y, that is equal to cos x. That means you cannot split easily. Here dy separately you can do. Okay. Even if you see y is equal to sin x plus 2 also you can do easily. Or else 2 plus y is equal to sin x also, what you are going to do? Y is equal to sin x minus 2. That means you are going to do dy by dx one side, another side completely x. Dy by dx. Okay, that means the function y is only one side, x is another side, or constants are another side. But here if you observe, you cannot take common here. This is y plus sin y is equal to cos x, means how you are going to take, how you are going to find dy by dx. Here they will ask you to find dy by dx. Find dy by dx. Find dy by dx, or find the derivative with respect to x, like that they ask. This is called implicit function. Why? Because see, you cannot split easily. Y plus sin y is equal to cos x. Okay, you cannot split easily. Here simply you have transferred to that side, and y d by dx of sin x cos x and 0. That means cos x you are going to get the answer here. Dy by dx is equal. Here how you are going to get dy by dx? This is okay. But what about this? What about this? This is also okay. But what about this sin y? Like chain rule we have to do. See what I am doing now. Okay, now how to tackle these implicit functions and all, I am going to explain to you how to tackle this. Okay, now what you have to do, you have to do derivative both sides derivative. You see what I am doing, dy by dx plus dy by dx of sin y is equal to d by dx of cos x. First you see what I have written. Why? Because this step is important. Then you can understand easily afterwards. Both sides I am doing derivative. D by dx of y, d by dx of sin y, d by dx of cos x. Okay. Whatever they come, first you goes and do. You see what I am doing. Dy by dx is last term. Dy by dx, afterwards you cannot do anything. That is why dy by dx like that only you keep plus. You see now here what you have to do. This side also very easy. D by dx of cos x is minus sin x. D by dx of cos x is minus sin x. But what to do this? First you see, let you treat y as x. D by dx of sin y is d by dx of sin x, like you think first. D by dx of sin x means what? Cos x. Write down cos x. X means what here? Y. Over? No. Again y you have to do. Why? Because it is not x. If not x something is there, means again you have to do up till x comes, or else dy by dx has to come into dy by dx. You understand now? This is the process in derivative of implicit functions we have to do. Okay. Now what is there? Now you see what I am doing. Now you see in both dy by dx is common. I am taking common. You see what I am doing? Dy by dx. If I take common, 1 plus cos y is going to come. That is equal to minus sin x. Okay? You understand now? This step. Dy by dx plus dy by dx cos y. Cos y dy by dx. Dy by dx cos y. Dy by dx I have taken common. Now you see, I want dy by dx. Then remaining I will send to out that side. You see what I am doing? Dy by dx is equal to minus sin x divided by 1 plus cos y. Is it okay? Definitely okay. That means this is the final result. Okay. You see here some cos functions have come. Trigonometric functions. What you have to do? You have to make sure that this denominator is not equal to 0. What you are going to do? You see here what I am writing. 1 plus cos y should not be equal to 0. Okay. But here some domain problems will come in the implicit functions and inverse trigonometric functions. Whenever trigonometric functions or implicit functions are going to come, then you treat that denominator shouldn't become 0. Denominator become 0 means undefined will come. Okay. 1 plus cos y should not become 0 means cos y should not become minus 1. Is it correct? Why? Because plus 1 minus 1, 0. Okay. Cos y, where it is going to become minus 1? Here 1, here minus 1. Why? Because cos, these both are plus, these both are minus. Okay, for cos. What is this? This is 2n pi, this is 2n plus 1 pi. Both is going to become n pi. But this is 2n pi. Here okay, 1. But here minus 1, this should not be there. 2n plus 1 pi. 2n plus 1 pi. That means you have to write here where y should not become 2n plus 1 pi. Like that you write and close. Okay? This is implicit function. What we do, one more example we take in implicit function. Then we go for derivatives of inverse trigonometric functions. In this class only we are going to derive all the results of these inverse trigonometric functions. Next class we will start exercise. Okay. Another example I am going to do for implicit function. Okay. Let us proceed. Okay. See. Next example we will take implicit function. This example. See what they have asked. Find dy by dx if x square plus xy plus y square is equal to 100. This is another example. Let us do this also. Then we are going to get some concepts. We are going to understand the concepts. You see what they have written? This is not a simple one. You see here x into y is there. Here y square is there. Y is not there directly. Separate y is not there. Separate y is there means explicit function. This is implicit function. Okay. How to do? Same. Derivation of both sides we have to do. Dy by dx like. You see what I am doing now. Okay. You see what I am doing. D by dx of x square plus d by dx of xy plus d by dx of y square is equal to d by dx of 100. Is it okay? D by dx of x square plus d by dx of xy plus d by dx of y square plus d by dx of 100. Okay. Now you see how to proceed like earlier you do. D by dx of x square is equal to 2x plus you see d by dx of xy means what? D by dx of x into y. Here y is not a constant. Y is not a constant. D by dx of x into y. D by dx of x into y means d by dx of u into v like v du by dx plus u dv by dx. V du by dx plus u dv by dx. Okay, this is for this one. Plus d by dx of y square. First to treat like this x square. X square means what? 2x. 2y, again t by dx of y, dy by dx, that is equal to, what about d by dx of 100? Constant function derivative is 0, you write 0, okay? Okay, now is anything need to be done? No. What you have to do, you see dx by dx is 1, but dy by dx you take common here. Okay, see what I am writing. Now dx by dx is 1, 2x plus y. 2x plus y plus, see dy by dx you take common. Dy by dx, if you take common, x is there, okay, 2y is there. That is equal to 0. First of all, you see, is it correct? Definitely correct, okay. Now what I am doing? See, first I will send this 2x that side, 2x plus y. Then again I am going to send this x plus 2y. Okay. Then we are going to get dy by dx. You see what I am doing? Dy by dx into x plus 2y is equal to minus of 2x plus y. Is it okay? Minus of 2x plus y. Okay. Now dy by dx you want finally write down. Dy by dx is equal to dy by dx is equal to minus of 2x plus y divided by x plus 2y. Is it okay? Definitely okay. This is final answer. Dy by dx. Find dy by dx. Dy by dx is this one. Okay. It may come in one y form. It may come in y form. You see, we will do if in y form. If any y is there, simply y, then you can convert, you can, what we can say, substitute also. Okay, you can substitute also y. That we will do in inverse trigonometric function. Okay, note down this. We will go for derivatives of inverse trigonometric functions. Okay, let us proceed. Okay, see, next concept is derivatives of inverse trigonometric functions. 6 inverse trigonometric functions we are going to find the derivative. I will box it, then you are going to note it down and you are going to take those as standards. See, until now we have got 7 standards. One is d by dx x power n, remaining all d by dx sin x, cos x, tan x, secant x, cosecant x. 6, okay? Those are normal trigonometric functions, derivatives. But these are inverse trigonometric functions, okay? All you have to note down as a standard. Okay, see what I am doing now. Now you see derivatives of inverse trigonometric functions. Inverse, y is equal to sin inverse x. Okay, see how I am finding this inverse derivative of inverse trigonometric function. You see, y is equal to sin inverse x means, shall I write x is equal to sin y? Definitely I can write. Why? Because see, y is equal to sin inverse x, x is equal to sin y. X is equal to sin y. Okay. See what I am doing now? Now I am doing derivation both sides. This is like implicit function only. Both sides I am doing. You see, d by dx of x is equal to d by dx of sin y. Is it correct? Both sides I am doing derivative. Both sides. Both sides. Okay. Now you see, d by dx of x is 1. D by dx of sin y means first you take it as sin x. D by dx of sin x is cos x. Write down cos x, x means y. Again dy by dx. Over. Once you do up to x, over. Okay. Here x has come. Here x has not come. That is why here x has come. Now you stop. Okay. Now you see what I am doing now. Observe carefully. Dy by dx I want. Dy by dx I am taking. You see, dy by dx is equal to 1 by cos y. Is it correct? Definitely correct. Okay, now you see, what is y? Y anyway you have to write dy by dx is equal to 1 by cos y. Y means sin inverse x. Cos of sin inverse x, if you write also, you cannot do anything. Okay? Y you convert into sin, cos you convert into sin. Why? Because here sin inverse x is what I am telling. You see, if I write cos of y as sin inverse x, it is not going to get cancelled. If I write this cos into sine form, sine of sine inverse x, then sine inverse are going to get cancelled, x is going to come. That means what I have to do, this you cannot convert. Why? Because this is y they have given. This you can convert to cos into sine. How to convert? You see, cos square theta plus sine square theta is equal to 1. Okay. Cos square theta is equal to 1 minus sine square theta. Cos theta is equal to 1 minus sine square theta under root. Is it okay? Now theta you take as y. Cos y is equal to square root of 1 minus sine square y. Sine square y means what you are going to write here? See, 1 minus sine theta. Theta means what you are going to write? Sine. Theta means here y. Sine inverse x. See, this sine square and root. Now you see what is going to come? Sine of sine inverse x is going to become. That means 1 minus x square. 1 minus x square under root. This is going to become this one. Okay, that is why we are going to convert this. Okay, let us proceed. Let us proceed. Okay, what I am writing, you see, comma I am keeping. Okay, now I am writing, you see, dy by dx is equal to 1 by 1 minus cos square y under root. Is it correct? First you see, sorry, sine square y. Square root of 1 minus sine square y under root. Okay. dy by dx LHS is okay, but what you see, 1 by cos y, shall I write 1 minus sine square by square root? Definitely I can write. Okay. Now you see what is going to happen. Comma dy by dx is equal to 1 by, you see, observe carefully, 1 minus sine square y means sine of sine inverse x whole square under root. Is it correct? First you see. Why? Because sine square means sine y whole square. Sine square y means sine y whole square. Sine y whole square. Okay. If I write like this, what will happen? This will happen. dy by dx is equal to 1 by 1 minus x square under root. Is it okay? Definitely okay. Why? Because sine of sine inverse x, x. Sine inverse going to get cancelled, x. Okay? X square, 1 minus x square, but under root. 1 minus x square under root. This is the final result. But you write again final result like this. You see what I am writing. d by dx of sine inverse x is equal to 1 by 1 minus x square under root. This you box it. But because this is one standard like you take it. Okay. d by dx of sine inverse x is equal to 1 by square root of 1 minus x square. This is one standard. Now see, d by dx of sine x is equal to cos x. d by dx of sine inverse x is equal to 1 by square root of 1 minus x square. You see, inverse function doesn't come trigonometric function. d by dx of sine x, cos x. d by dx of cos x minus sine x. Again trigonometry has come. RHS. LHS is d by dx of sine x. RHS is d by dx, cos x. But here trigonometry will not come. You see, d by dx of sine inverse x. But here trigonometry will not come. All inverse trigonometric function derivatives trigonometry will not come. Okay. This is okay. But what is the value of x? Why? Because here 1 by x square should not become 0. That you have to keep in your mind. What you are going to write here? See, 1 minus x square under root should not become 0. 1 minus x square under root should not be less than 0. Both you have to consider. Why? Because see, this is square root. First of all, this should not become 0. If it becomes 0, what will happen? Undefined will become. That is why 1 minus x square under root should not become 0. That means here x is if minus 1 or plus 1. Then this is going to become 0. That is why what you are going to think? X should not be minus 1, x should not be plus 1. First, you see, we are proceeding the domain, but slowly we are reaching. You see, x is 1 means 1 square 1, 1 minus 1, 0. Denominator is going to become 0. Minus 1 also, minus 1 square is 1. 1 minus 1, 0. Okay, that means x should not be minus 1, x should not be plus 1. Okay, what about 2 minus 1? If x is greater than 0, what will happen? X is greater than 0. Say x is 2. 2 means 2 square 4. 1 minus 4 minus 3. Square root of minus 3? No real number. Again we are going for complex numbers. That is why x should not be greater than 1. Okay? In minus side also, x should not be less than minus 1. Minus 2 square minus plus 4. 1 minus 4, again minus 3 will come. Square root of minus 3 doesn't have a real number. Okay, that means the value should be like this. You see, x belongs to minus 1 to plus 1 open interval, not closed interval. That means you should not give minus 1, you should not give 1, but you can give only minus 1 less than, greater than minus 1, less than 0, less than 1. 0 also you can give. You understand now? See, in the real number, this is 0, this is minus 1, this is 1. Okay, this only you can give. But minus 1 and 1 you cannot give. Okay, in between also several things are there. Minus 0.5 is there, 0.5 is there, 0.25, 0.75. All are there. Those values you can give here. Okay, that you keep in our mind. Okay, let us proceed for cos inverse x. Okay, first you take this standard, then we are going. See, this also you note down. Domain x, where x belongs to minus 1 to 1, and this minus 1 to 1, this is not there. Closed bracket. Closed interval means you can give. These extreme ends also you can give. Open interval means extreme ends you should not give. Okay, like that. Let us proceed for d by dx of cos inverse x. Okay, let us go. Okay, see, d by dx of cos inverse x we have to find. Y is equal to cos inverse x. Okay, this is the function. Okay, implicit function they have given. Then we are going to find cos inverse x also. Okay, see what I am writing. If y is cos inverse x, x is equal to cos y. Write down. X is equal to cos y. Okay. Now what you are going to do? You are going to do derivative both sides. That's all. d by dx of dx by dx is equal to d by dx of cos y. Is it okay? Definitely okay. Okay. Now dx by dx, or d by dx of x is 1. d by dx of cos y, you take first y as x. d by dx of cos x is minus sin x. Minus sin x means what here? Y. Again into dy by dx. Is it okay? Definitely okay. But what you want? You want dy by dx. Then you keep dy by dx one side and send the remaining other side. Okay. You see 1 by minus sin y it is going to become. But what I am going to do? This minus I am going to transfer numerator. dy by dx is equal to minus 1 by sin y. Okay, this is also okay. But is it over? No. Why? Because see, in y area, if you send cos inverse x, y is equal to cos inverse x. Sin of cos inverse x means it doesn't give any result. That is why what I am going to do? I am going to write sin y as square root of 1 minus cos square theta. Is it okay? Definitely okay. Sin theta is equal to square root of 1 minus cos square theta. Okay. Same thing I am going to write again here. Okay. You see what I am writing. You see what I am writing. dy by dx is equal to minus 1 by 1 minus cos square y under root. Is it okay? Definitely okay. dy by dx is equal to minus 1 by sin y. I have written 1 minus cos square y. Why? Cos square y means cos inverse cos. Cos inverse are going to get cancelled. Then we are going to get y. Okay? Write down. See what I am writing now. Comma dy by dx is equal to minus 1 by square root of 1 minus. You see I am putting bracket. You see, simply observe how. Cos of y, cos inverse x, okay, whole square. Is it correct? Definitely correct. Okay. Now you see, cos of cos inverse cancel, x will come. Okay, you see now what I am writing. dy by dx is equal to minus 1 by 1 minus x square under root. Cos inverse are going to get cancelled, x is going to come, but x square is there, cos square. Okay, this will come. Finally, you write down d by dx of cos inverse x is equal to minus 1 by 1 minus x square under root. But you take this as a standard and box it. Box it. This is also another standard. d by dx of cos inverse x is equal to minus 1 by square root of 1 minus x square. Here also domain what you are going to give for x? Same what you have given earlier. X belongs to minus 1 to 1 but open interval, not closed interval. Why? Because see, less than minus 1 gives also this root is not going to give result. Minus 3 or minus 2 will become. Greater than 1 if you give also, minus root will come. Minus root, not real root. And minus 1 gives 0 will come. 1 gives 0 will come. That is undefined. It is going to become. Okay. That is why this is domain for this one. Okay. See, domain for both same. And identities also, standards also same have come, but for cos minus has come, you see. Okay. For sin 1 by square root of 1 minus x square, for cos inverse minus 1 by square root of 1 minus x square. Okay, see, by seeing this you can find one thing. See, shall I write like this? You see, d by dx of cos inverse x is equal to minus of d by dx of sin inverse x. Is it okay? Definitely okay. Why? Because see, d by dx of sin inverse x what has come? 1 by square root of 1 minus x square has come. But you keep minus. Then here also you see minus 1 by square root of 1 minus x square has come. Both are same. Or you can write like this. If you multiply with minus, minus d by dx of cos inverse x is equal to plus d by dx of sin inverse x. Both are same. That means both are opposite negatives. That means cos inverse x and derivatives of cos inverse x and derivative of sin inverse x are negatives each other. Negatives each other. Okay. Like that you can think. Okay. Minus has come. For tan plus will come. Sorry. For sin plus will come. You have to keep again minus outside. If you want to equate it to cos. And domain for both they are same. Okay. You take this second standard. And the third standard tan inverse x we are going to do. Okay, let us go. Okay. See, y is equal to tan inverse x. We want to find the derivative of tan inverse x. Same like earlier only. X is equal to tan y, you write down. X is equal to tan y. Now you proceed derivative of both sides. Dx by dx is equal to dy dx of tan y. Is it okay? Definitely okay. Then another one, this is 1. 1 is equal to d by dx of tan y. You see, d by dx of tan x is secant square x. Secant square x means here y. Okay, again into dy by dx, implicit function. Okay, comma. But you want what? You want only dy by dx. You keep dy by dx one side and send secant square x out that side, opposite side. Is it okay? Definitely okay. That means dy by dx is equal to 1 by secant square y. Okay. Now you proceed further. Why? Because see, secant square y cannot substitute. Why? Because secant to tan not going to give any result. But you can convert secant square into tan. What is that? 1 plus tan square theta is equal to secant square theta. That means whatever I am writing secant square y, secant square, if you keep here y, automatically here y will come, tan square y. That means I am writing this as 1 plus tan square y. Why? Because tan of y, tan inverse x is going to come. Okay, like that I am going to do. Okay, let us proceed. Let us proceed further. You see what I am writing? dy by dx is equal to 1 by 1 plus tan square y. Shall I write like this? 1 plus tan square y. Secant square y is equal to 1 plus tan square y. 1 plus tan y whole square. Okay? Comma. You see what I am writing now? dy by dx again you write is equal to 1 by 1 plus tan of y is tan inverse x. Is it okay? 1 plus tan of tan inverse x. Okay. Y is equal to tan inverse x. Okay. Now you tell me tan of tan inverse x. This is y. Tan y. Tan y. Y is tan inverse x. Tan of tan inverse x is x. You see what is going to become this one? That means dy by dx is equal to 1 by 1 plus x square. Why? Because this entire thing is going to become x square. 1 plus x square. Okay. But you write standard. Standard. What I am writing, you see. Comma. D by dx of tan inverse x is equal to 1 by 1 plus x square. Okay. Now box it. Why? Because this is like a standard you have to take. Again and again we need not derive this. We have derived. Okay. First of all you take this. Now we analyze domain x. X belongs to what? X belongs to R. Why? Because see here x square is becoming minus 1 if you give also plus 1 it is going to become minus 1 square. Plus 1 if you give also 1 square 1. 1 plus 1 2. Minus 1 also 2. Plus 1 also 2. 0 also nothing will happen. 0. 1 plus 0. Okay. That means from minus infinity to plus infinity anything you can give domain. That means we can say R real number. Any real number you can give for tan. D by dx of tan inverse x. Understand? Take them. We will go for cot inverse x. Okay. Okay. See now we are going to find a derivative of a cot inverse x. Fourth derivative. Okay. Cot inverse x. Cot inverse x we are going to find derivative. Shall I write this as x is equal to cot y? Definitely I can write. Okay. Write down first. X is equal to cot y. Okay. Now what you are going to do? You are going to do derivation both sides. D by dx of x is equal to d by dx of cot y. Write down. Dx by dx is equal to d by dx of cot y. Is it okay? Definitely okay. Okay, d by dx of x is equal to d by dx of cot y. Okay. Now you see d by dx of x is 1. D by dx of cot x minus cosecant square. Minus cosecant square x means here what? Y. dy by dx. Is it okay? Why? Because d by dx of cot x is minus cosecant square x. Minus cosecant square y into dy by dx. Okay. But I want dy by dx only. Then you send this that side. Dy by dx is equal to, you see, 1 by minus cosecant square y. This minus I am going to transfer at top. Numerator. Cosecant square y. Okay. Now also you see, here cosecant is there. Cosec. Here cosec is there, but here cot is there. Then both are not going to mismatch. This cosec I want to transfer in cot. Then I can apply this. Okay, you see what I am writing here. Okay, 1 plus cot square theta is equal to cosecant square theta. This formula we know. That means cosecant square y I am going to write 1 plus cot square y. Okay, okay, you see what I am writing. Dy by dx is equal to, okay, minus 1 by 1 plus cot square y. Is it okay? Definitely okay. Okay. Now I am going to substitute this. You see what I am doing. Comma dy by dx is equal to minus 1 by 1 plus cot of cot inverse x. Cot of cot inverse x, but whole square. Okay. Cot of, see, cot is there. Cot of cot inverse x. Why? Because y means cot inverse x. Y is equal to cot inverse x. Square. Okay. Now you tell me what is going to happen. Dy by dx is equal to minus 1 by 1 plus x square. Is it okay? First you see. Why? Because cot of cot inverse x is x. X square. 1 plus x square. Minus 1 by 1 plus x square. Now you write standard. Standard I am writing again. D by dx of cot inverse x is equal to minus 1 by 1 plus x square. Okay. Now this you keep one box. This is another standard, fourth standard. Okay. Sin inverse, cos inverse, tan inverse, cot inverse. Fourth standard. Okay. Now you tell me what you can give domain x. Same like tan, all anything you can give. X belongs to R. Why? Because this is not going to become undefined. Why? Because it is going to make square and add to 1. 0 also added to 1, 1 will become. That is why x belongs to R. Anything you can give, minus infinity to plus infinity, anything you can give domain. Okay. This is one thing. Second thing you see, have you observed with tan? D by dx of tan inverse x is equal to minus 1 by 1 plus x square. D by dx of cot inverse x is equal to, cot inverse x is equal to minus 1 by 1 plus x square. Tan inverse x is equal to plus 1 by 1 plus x square. Then what you are going to write? You are going to write like this, you see. What I am writing. D by dx of cot inverse x is equal to minus of d by dx of tan inverse x. Is it correct? Why? Because for tan, minus will not come. You have to keep outside minus. Then it is going to become cot inverse x. Okay. Both are vice versa. Both are negative. That means cot inverse d by dx of cot inverse x. Derivative of cot inverse x is negative of derivative of tan inverse x. Derivative of tan inverse x is equal to derivative of tan inverse x is equal to negative of derivative of cot inverse x. Like that you can take. Okay. Take this. We will go for fifth one. Secant inverse x. Okay. Let us. Okay. Now let us take secant inverse x. Derivative of secant inverse x we are going to find. But first you take function y is equal to secant inverse x. Okay. I have taken. Then what I am going to write this? I am going to write like this. X is equal to secant y. Is it okay? Definitely okay. X is equal to secant y. D by dx of secant inverse x. We are going to find. Okay. X is equal to secant y means you are going to do derivative both sides. Dy by dx of x is equal to dy by dx of secant y. Okay. Now you proceed. D by dx of x is 1. D by dx of secant x was what? Secant x tan x. But secant y tan y over? No, dy by dx. Is it okay? Definitely okay. D by dx of secant x is equal to secant x tan x and dy by dx. Okay. Now you see, secant y means y you can substitute easily. dy by dx, let us write first dy by dx. dy by dx is equal to 1 by secant y into tan y. Is it okay? Definitely okay. But you see now what is happening here. Secant y means y you can substitute to secant inverse x. Secant of secant inverse x, x is going to come. But when tan is there, you cannot substitute to secant in tan. Then how to convert this? Again we got one formula. You see what I am writing. That formula. 1 plus tan square theta is equal to secant square theta. Okay. Now you want to tan y. Tan square theta is equal to secant square theta minus 1. This 1 goes that side. But you want to tan theta. Tan theta is equal to square root of secant square theta minus 1. Now rather than theta I am putting y. Tan y is equal to secant square y minus 1. Okay. Like that you have to write. Write down. That is equal to dy by dx is equal to 1 by, for secant y I am substituting directly, secant of secant inverse x, secant inverse x, y, okay, into, for tan y I am writing tan y, square root of secant theta, y, secant inverse x, but whole square, minus 1. Is it okay? Okay? But you see what is going to happen. Dy by dx is equal to 1 by, this is going to become x, secant of secant inverse x, x. But this you see, secant of secant inverse x, x, but whole square, x square, but under root, x square minus 1. That you have to keep in our mind. Okay. See what I am writing. You write down here. D by dx of y is equal to 1 by x into square root of x square minus 1. Is it okay? First you see what I have written there. Why? Because see, this is going to become x, x. This is going to become x, x. But square is there, minus 1. Square minus 1. Dy by dx is equal to 1 by x into square root of x square minus 1. Okay, now you write like a standard, not dy by dx. You write down d by dx of secant inverse x is equal to 1 by x into square root of x square minus 1. Okay. Now you box this. This is a standard, like all standards you see, d by dx of secant x is equal to secant x tan x. But here d by dx of secant inverse x is equal to, not the trigonometry will come. Real values, sorry, variables are going to come. Okay. This you take one standard, like, okay, this is one thing. Another thing, what is the domain? You study first how to do. Domain, x should not be 0. Why? Because if it's 0, automatically 0 into something, this is going to become 0, this is going to become 0 minus 1, minus 1 under root. This is also not valid. This is going to become undefined. X should not be 0. Okay. Then what you can do for coming minus 1, that means x should be greater than 0. Okay. Now you see here, what is that one? This value. for not coming negative root. 1 comes 0, it is going to become, that is why x should not be 0, 1. X should not be -1. Is it okay? Definitely okay. Then what it can go? You see what I am writing now. X belongs to -infinity to -1 union 1 to infinity. Is it okay? First you see domain. That means -infinity to -1 you can go, but -1 you should not give, -infinity you should not give. Okay, -1 to -1 you should not give again. Is it okay? You may tell, sir, if minus is coming, so let us come minus. What is happened? Here if minus comes means it is going to become plus. More than -1. Say -2 I have given. -2 if you give, -2 square 4. 4 minus 1 3. 3 root is there. But outside minus is there. Even though let it be, minus will come, but undefined is not going to become. You understand now? That is why greater than -1, less than -1 up to -infinity you can give. But -1 you should not give. -1 if you give, automatically 0 it is going to become. That is why open interval, not closed interval. 1 also you should not give. 1 gives 0. Okay. Greater than 1 you can give. 2 if you give, 2 square 4 minus 1 3 will come. Here also 2 is there. Defined up to infinity. Okay. This is the domain for this secant inverse x. Okay. Okay. Let us proceed for cosecant inverse x, last one. Okay, let us proceed. Okay, see, cosecant inverse x. Y is equal to cosecant inverse x. Okay, now we have to find the derivative of this cosecant inverse x. We have found until now 5 derivatives, so standards like we have taken. Now cosecant inverse x also we are going to find. You see what I am writing? X is equal to cosecant y. Is it correct? Definitely correct. Y is equal to cosecant inverse x. If you send function this side, inverse it is going to become. And if you send the inverse function that side, normal function. Okay? Okay. Now, see, it has become x is equal to cosecant y. Now you make derivation both sides. D by dx of x is equal to d by dx of cosecant y. Okay? D by dx of x is equal to d by dx of cosecant y. Okay, that also we have written. Now d by dx of x is 1. D by dx of cosecant x minus cosecant x cot x minus cosecant x means y, cot x means y, dy by dx. Is it correct? First you see, d by dx of cosecant x is equal to minus cosecant x cot x, but y is there. Y you have to write. Okay, y written. Now I want dy by dx only. Then you send remaining all one side. Minus 1 by cosecant y into cot y. Is it okay? See, minus is there. Denominator minus I have sent to numerator. 1 by minus cosecant y cot y it should become, but minus I have sent to numerator. Okay. Now you see, cosecant y is okay. Cosecant inverse x you can substitute in y plus. Cosecant 2, cosecant inverse are going to get cancelled. X will come. What about cot? You see what I am writing? 1 plus cot square theta is equal to cosecant square theta. Cot square theta is equal to cosecant square theta minus 1. Cot theta is equal to square root of cosecant square theta minus 1. Is it okay? Now this cot y I am writing as cosecant square y minus 1. Why cosecant square if I write, cosecant inverse is there. In theta place, I can put cosecant inverse x. Cosecant inverse cosecant. Both are going to get cancelled. X is going to become x square. x square minus 1 it is going to become. Okay, like that I am going to do. Okay, let us do. See what I am writing. dy by dx is equal to minus 1 by cosecant y. Okay, cosecant y means cosecant inverse x into cot I am writing cosecant of theta y, cosecant inverse x, but this is going to become whole square minus 1. Is it okay? Now what result is going to come? This is going to come. You see what I am writing. dy by dx is equal to minus 1 by, this is going to become x, this is going to become x square minus 1 but under root. Okay. But you write like standard. Now I am writing like a standard. You see what I am writing. d by dx of cosecant inverse x is equal to minus 1 by x into square root of x square minus 1. This make one box. First let us see domain. Then we will compare with secant inverse x. Domain is what? Like earlier only. Like this you can give. You see what I am writing. Domain. X belongs to minus infinity to minus 1 union 1 to plus infinity. This you can give. That means see open intervals. Minus 1 you should not give, 0 it is going to become, 1 you should not give, 0 it is going to become. More than 1 you can give by, because see 2 square 4 minus 1 3 and outside also 2 will be there. Definitely. Less than minus 1 also you can give minus 2. Minus 2 if you give 4 will come 3 and minus 2. Minus result. Minus minus going to get cancelled. That is different, but undefined it is not going to become. But if you give greater than minus 1 and less than 1, then this is going to create problem here. Why? Because root is not going to come. Real root. Okay. We are talking about real numbers only here. This is the case for cosecant inverse x derivative. Inverse derivative. But if you see here also, you see secant 1 by a has come. For cosecant inverse minus 1 by a has come. What you can write? You can write like this, you see. d by dx of cosecant inverse x is equal to minus of d by dx secant inverse x. Is it okay? Both are negative each other. d by dx of cosecant inverse x is equal to negative of d by dx of secant inverse x. d by dx of secant inverse x is equal to negative of d by dx cosecant inverse x. Derivatives. Both derivatives of inverse secant and cosecant are negative each other. Okay. What we do? We stop this class here. We will meet in the next class. We will start exercise 5.3. Okay. Thank you very much.